Hello, my name is Zorz. I come from Slovenia. And actually this will be a long rant. Not a talk, but a rant. What am I talking about? We have been thinking about the vision in trade-offs space in transition mechanisms that we want to use to move to IPv6 actually. And we put together this stuff together with Randy Bush, Dan Wink, that was Mr. Nat, Mark Townsley, that was Mr. Tunnel, and I also used some slides from Jeff Houston, that he's Dr. Doom. Let's see what we actually achieved. Well, slides were put together by Ola, but just so I used basically his slides just because I'm a bit lazy. So, about me, I'm a CEO and founder of Slovenian Go6 Institute. We also do IPv6 consultancy for many Slovenian operators and enterprises. So if you need some IPv6 info, talk to me. I've been working in internet operations for 21 years. And 12 years ago, I touched IPv6 and been using it since then heavily. I'm a contributing member of RIPE and IETF community. We did some good stuff for RIPE, like RIPE 501. Which one of you knows about RIPE 501 paper? It's procurement stuff that actually sets the standards how to require IPv6 when you're buying equipment on tenders or public tenders and so on. And I'm also co-author of RFC 6346. That's A plus P. That's address plus port approach to IPv4 depletion. And I'm also a frequent IPv6 flyer. I've been all around the world invited as a speaker at many conferences as this one. So, we had an idea that actually internet at the beginning was a free space where actually hosts talk to each other. And then all these tunnels and translation came and started wrecking the beautiful idea of the internet. So we had the idea to put together Randy Bush. He was here, I think, in 2008 in PLNOG. He's Mr. Vision. He says that internet must be simple, no complexity at all. Like he's proponent of the old idea of old good internet. Then we had Mark Townsley. He's Dr. Tunnel. He's my dear friend. And he actually standardized and wrote the code for L2TP. So he is, in this industry, he's Dr. Tunnel. He's tunneling stuff. And then Wink. Then Wink is he's Mr. Translation. He's a chair of, what's that working group name at IETF? Behave, yeah. He's chair of Behave working group. And actually he is Dr. Nat. He hates Nat, but actually in his working group, all the natting and translation is being done. So we put together the panel in Ljubljana IPv6 summit that we had in Slovenia. And look here, Randy came, Mark Townsley came, and I was chairing this discussion. And my presentation today is the summary of what we put together then. So we have IPv4, right? And evolution should be IPv6, right? Where are we today with IPv6? Today, here, right? Size of the internet is going up. IPv6 deployment probably will happen. IPv4 pool size is going down. So we are not where we wanted to be like 10 years ago. You see, these are the graphs from Google. We have Teredo going down. We have a native internet going up, but these are very, very small percents, like 0.4% and so on. Who deploys IPv6 today, right? Those people who are really enthusiasts, those who are encouraged by a government. Then it's a fear factor, saying, okay, if we don't deploy IPv6, we will, I don't know, world will collapse. There are some people that sees the new opportunities in IPv6, which is good. And there are some people that sees the green field of their app application, so they can actually build applications in old internet way, right? So, why has the transition to IPv6 been so slow? You ever asked yourself this question? Why it was so slow? Is it the vendors? Is the lazy operators? Huh? Some people claim that some IPv6 idealists claim that it's the operators. Is it the lack of content? We don't know. Right? Is it the applications that does not support IPv6? We don't know. Is it the CPE? No. No. CPEs are ready. There are some vendors that are shipping out the IPv6 CPEs. In Slovenia, our incumbent telecom is shipping out IPv6 CPEs. Where's the problem? Those who claim that CPE is a problem, my usual response is, no, it's not a problem. You just need to buy them. Put the money where your mouth is, right? Is it the end user host stack? No, right? Isn't the 430 transition mechanism that we managed to invent? So IPv6 deployment is not so slow because of lack of transition mechanism, right? Problem is that transition depends on all of those at the same time, and this is a recipe for a failure, right? You need to have all these ingredients to be able to go to IPv6, actually. But we have one much larger problem. See? Anyone see the problem in this picture? IPv6 is on the wire incompatible with IPv4. And this is the core problem. It's on the wire incompatible. Those people who designed IPv6, okay, I will not say it, were not very bright at that moment. They could use some tobacco in what they smoked. Right? There was no transition plan. And how did this happen? Actually, it's arrogance and lack of operational clue in the ITF. In the ITF, they are good. They are academics, and they are vendors. There is no operational experience in the ITF. They design protocols, and there was one very good paper written by Randy Bush that said IVTF, Internet Vendors Task Force. And actually what they're doing is they're throwing a spaghetti into the wall and see what sticks. Right? If the spaghetti sticks on the wall, then that technology will stay. But the wall are the operators. Right? They're throwing new technologies into the walls of operator. And if sticks, then it's done. Right? There was no transition plan. Because when they invented IPv6, nobody cared. Because they said, okay, people will deploy IPv6, and IPv4 will go down. This did not happen. And now we are stuck with it. We don't have any other option other to deploy IPv6. that is incompatible with the old protocol, right? So we have a leap, right? It's a leap. It's not a transition. It's a leap, actually. So the transition from IPv4 might go to CGNs and to CDNs, ALGs, and then to IPv6. Anyone sees a problem in this picture? Vendors are very happy about this circle. Very, very happy. Because all the others will pay a lot of money to the vendors for big boxes, right? So, where is the exit point, right? Not everybody will come to IPv6, right? And if you deploy this, if you deploy this, if you deploy this, you end up with the big boxes, right? So the IPv4 internet was a simple place where packets were just flowing, right? It was like this. It's a river. I don't know. But we can easily destroy this environment in a year or two. If we're going to deploy these multi-million-dollar big boxes that vendors are trying to sell, we can easily destroy the environment in a year or two. Right? See? We have 32 bits, we have 128 bits, and the big hurdle in between. Right? But there is one serious problem with CGN. We had the salmon. We tried to jump from here, up there, over the CGN. Right. This is the big, big, big problem. We can't jump. We just cannot. We just can't. And when the vendors say service continuity, what they mean it, they're not transitioning to IPv6. So if you say, I need a service continuity, then you are not transitioning to IPv6. You are just supporting IPv4 as long as possible, right? See? Try not to do that. Try not to do that. Don't connect yourself to a CGN box and try to leave. Right? You see, the problem is in this picture. These guys meant good. They wanted to install these poles. They parked the car and started the work. How the hell are they going to get out? There is no exit strategy here. And it's the same with the CGNs. You have no exit strategy. Right? And think about the world where you can, I don't know, if I want to deploy a new service, I just build the application, send it to you, send it to you, send it to you, and we start communicating. Right? If I want to build, I don't know, Skype 2, then I just distribute the application and we start talking to each other. Imagine the world where everybody would have to call his operator, telecom, or Apple or Google or something else, to say, hey, can you install the ALG into your big CGN because my application is not working? What do you think? What would the response be? Right? They would say, okay, go away. Right? And so if we don't want to end up in the world like that, we need to think about end-to-end principles of the stupid core and the smart edge. If we move the intelligence into the core, we end up like a SIP system, like a telephony system. Can you imagine deploying a new service on a SIP server? No, right? It's hard. So if you keep the intelligence on the edge, then this is one of the first principles of the internet. And I'm now taking role of Dr. Tunnel, Mark. Actually, there are two types of transition mechanisms. One is IPv6 service, one is solving IPv4 exhaustion, and we have interoperating mechanisms. But we need to distinguish. Is it actually transitioning to IPv6 mechanism, or it is a regression mechanism? Right? If we are regressing back to v4, then it's a regression mechanism. So we have like 6RD, L2TP. We have lots of this useful stuff that probably will have to go away in some point in time, like a Teredo, ISADEP. For example, there was very good work done with, from Hurricane Electric and Martin. They provided the tunnels. They acted as a tunnel broker, and this helped a lot into transitioning to IPv6 because they had this knowledge centered. You could do the tests, you could become a sage, and so on. So this was helpful. Then we have IPv4 exhaustion. It's called IP address sharing. I'm the co-author of A+P. That's mapping of address and port. So we are sharing the public IPv4 address at the CPE level. Then we have these regression mechanisms like a CGN and SDNet. And we have DS-Lite. This DS-Lite is it's a bit scary because it's extended CGN, but the packets are embedded in IPv6 packets. So actually, if you want to set up a DS-Lite, you must introduce IPv6 in your network, right? And then we have these translation mechanisms that are translating from one protocol family to another. So this is an interesting quadrant. We have states. So these mechanisms are stateful. This is where vendors are very happy. This side is stateless. So this means smaller box, more users. You don't keep state. If you introduce the big state machine in your core, wow, you're going to pay more and more money every year, and you're not going to remove that multi-million-dollar box. And here we have up and down. We have actually if it's progressing to IPv6 or not. So we have all these tunnels that were cool, but probably they will have to go away in some points in time. And actually, this quadrant is the best one, right? We have map, that's A+P. It's called 4RD now. We have 4RDE. It's stateless. We have 4RDT, DIVI, DIVI-PD, and 4RDU. So there are lots of transition mechanisms, but you need to understand which ones brings you what, right? And lots of people said that they printed out this quadrant and put it on the wall in their office. So they are looking at it every day. Right. So about the tunnels, what goes in must come out, right? And that's why tunnels are heavily used for transition mechanisms, right? They're often not perfect, but they're good enough. Right? Okay, we know we have MTU issues. We know that the packet inside the tunnel cannot decide on which way the packet wants to go. But they act like a data link layer. And I can't decide if tunnels are good or bad. Right? For some specific purpose, they're probably good. And they were invented for some reason. But they are heavily misused. right? So internet is now ending to be a place populated with tunnels. And we really don't want that, right? So what David Wheeler said is that all problems in computer science can be solved by another level of indirection, except for the problem of too many levels of indirection, right? And tunnels can give us some levels of indirection, right? And there are a wide variety of uses with tunnels, right? I think this is somewhere in Sicily. I wouldn't be surprised. So, the problem with address sharing is a NUT placement, right? You want the NUT to be placed as close to the user as possible. At CPE level, we are using it now, right? Well, I don't, but probably most of you guys are using NET at the CPE level. Let's keep it that way, right? So, for example, this is for map or 4RD. Actually, that you have IPv4 and IPv6 world. You have this IVI box that translates or encapsulates IPv4 payload in IPv6 packet, sends it over the access network to the CPE, where you have IVI to translate or decapsulate packet back from IPv6 to IPv4. And this is somehow working. What are the problems with IP address sharing? We are sharing the address, but we are not sharing the ports. So every user will have a limited range of ports. And sometimes you run out of ports. For example, this Google Maps is heavy on port usage. And if you run out of ports, this happens to you, right? We need to understand what we are doing. And we have like lots of mechanisms, and we need to understand IPv6, IPv4, right? This is, you have the whole this IPv4 address sharing with CGN net44, SDNet. This SDNet thing, it makes me sick. Wow. Stateless deterministic network address translation. Come on. It's crap. And we have IPv6 mechanisms that you have, for example, 6RD that uses IPv4 to carry IPv6 packets. We have dual stack light, we have map, and these two are native, right? So, how do we connect IPv4 to IPv6? Well, we use NAT64. And this NAT64 will be heavily used by mobile operators. Actually, lots of mobile operators are taking this NAT64 as a strategy. And I say, better NAT64 than NAT44, right? With the NAT64, you have the exit strategy. With NAT44, you don't. Remember that van? Right? No exit strategy. So, I told you that. So, the principle of smart edge and stupid core, right? I already told you that. I have this twice. So, conclusions. This is actually a picture that Dan Wing wrote, Dr. Nat. And he put his stuff into the far bad end, right? So, native routing works, layer 3 works. Tunnel, if you have to, and use as less translation as possible. So, let's see the dual stack transition leap, right? You want to go from here to there, right? Let's use the transition steps instead of a leap, right? So we can go dual stack network here, dual stack users here. We use the tunnels in between, right? Then we can go to dual stack network and dual stack users, and we can then transition to IPv6 only network. So we have a transition mechanisms that uses IPv6 to carry packets, right? And at the end, we will have IPv6 only users, IPv6 only network, and dual stack in internet. For example, for mobile operators, this is possible today. There are phones that supports IPv6 on 3G. I have one in my pocket. And they are using Net64 in the core. So their network end users on the phone are IPv6 only users. And if you are operator with the fixed access, not mobile operator, your steps will be a bit longer. It will take longer for you, but eventually in few years you will get there. Yeah, yeah, probably. Yeah, so you introduce the state, right? You must be careful. Placing a state machine is a hard engineering problem, right? If you want to effectively use the NAT, then you need to place it in the core. But then you have lots of states to maintain, right? If you put it to the edge, then it's not effectively used, right? Yeah, probably. So IP address sharing is necessary to keep the business running, right? And we need to keep our users happy. If we do the transition to IPv6 without our users even knowing it, we all won, right? Users must not see the difference, right? And now we have this trade-off space in transition mechanisms. What we're going to use? What we're going to do? Right? So there is principle number one. Choose mechanisms that are actual progress towards IPv6. Choose the mechanisms that carry IPv4 traffic in IPv6 packets. Remove IPv4 from your access network. Use only one protocol. Use IPv6, and your operational cost will go down. You are not provisioning two protocols. You provision only one. And remember, there are transition and there are regression mechanisms. Choose wisely, right? Prefer mechanisms which are simple, stateless, and use IPv6, not IPv4. And keep state at the edge. The internet was built to have state at the edge, not in the core, right? And use mechanisms which preserve end-to-end and other basic principles as much as possible. Do it as simple as possible. Don't add complexity to your network, because it will never pay off. When something goes wrong in your network, if you have a complex network, it's really, really hard to troubleshoot it, right? And at the end of that panel discussion, that was discussed, and there was a long, long, long discussion, and Ljubljana Declaration came out. I will not read it for you. Read it for yourself. Right. So, this is it. Are there any questions?
I suppose nothing's going to happen, I mean, or just a little, until the moment when somebody in Europe will be refused by RIPE to get more IP addresses because of no resources. So then, which way you think it's going to be chosen? Isn't it going to be like a panic and picking up first solution which some vendor will propose?
Hope not. That's why I'm here. That's why I'm telling you this. Right? They expect the ripe to be depleted somewhere in May or June, but actually we don't know.
This
right?
year?
This year. Actually we don't know because usually Jeff Houston runs around with his graphs predicting when somebody will deplete, but this is not working this way. Mm-hmm. I had a discussion with ripe staff, and they said, we don't know when we're going to deplete, because if, I don't know, Deutsche Telekom comes with a big request, they might take a big chunk of what's left. If they don't come, or France Telecom, or British Telecom, or whoever big can get the space, and then they just deplete everything. So we don't know. It may happen tomorrow.
Uh-huh.
So we don't know. It may happen tomorrow. It may happen next week. It may happen in May or June. We don't know. Mm-hmm. So we need to think about the transition now. And we need to look at the solution space and choose wisely. The easiest solution for the operators is to install the CGN. Wow, lots of money, multi-million-dollar box. But they install it, but the problem is when these people will realize that there is no exit strategy, they will never remove this multi-million-dollar box, because the guys from finance will say, what, we paid multiple millions of dollars and now you're saying it's bad? No, 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 no. Use it, we paid for it. Right? So it's all about the what you choose, and you need to choose wisely.
Okay. So if possible, implement for subscribers parallelly at the moment V6, V4.
Yeah, it is.
And let's pray that all the contents in the core will be more available in V6.
On 6th of June, there will be IPv6 launch day. So Google, Facebook, Yahoo, and all the big providers will enable IPv6.
There will be dual stack, yes?
Yes.
Productively.
And yeah, in production.
In production.
Right? So here is your paper, right? You need to choose from that. Right? And when you think of that, choose wisely. Okay. About the content, we can expect the big jump in IPv6 traffic on June 6th, and I hope it stays there. Martin had a good presentation in room 4, just before me. He was talking about that. And this will also be an incentive for people to enable IPv6 in their network. Any other questions?
Maybe not exactly the question, but the comment that you mentioned that vendors are pushing towards stateful solutions, but exactly it is the opposite, because vendors are, from my perspective, I'm from Cisco, I'm pushing towards stateless for operators, because there is no point for the solution to have too complicated solution which is not supporting asymmetric routing, for example, and stateful translation does not support asymmetric routing as it is in the internet. So because of this reason, stateful solutions are not reasonable. So keep it simple, stupid solution is also a good perspective from the vendor. Anyway, the second comment is that in some situations we can, of course, translation is not good, but we cannot avoid this. And again, stateless translation is better than stateful. And so my question is, why do you think that stateless deterministic NAT is so bad? Because we have one example of already implementation in one of the mobile operator in Poland, not on Cisco actually, on Juniper, where stateless deterministic NAT was used. Why don't you like this solution?
Because it is a regression mechanism. It is actually not helping IPv6 deployment at all. And actually what Reynaldo wrote in SDNet, I know Reynaldo very well because he's co-author of A+P with us. What he wrote in SDNet draft is that one of the good points of SDNet is that it can be implemented without implementing IPv6, so later on the operator can decide on IPv6 strategy. This is bad. This is really, really, really bad.
All right, from the political reason I agree. From the technical thing, it's good enough as a temporary solution, isn't it?
You know that
I know that temporary solutions are
most permanent ones.
Yes, exactly, which we should avoid. I agree, but sometimes business continuity is sometimes more important. So I agree that we should avoid this, but sometimes
actually
it's not
I know
possible.
from very trusted sources that the company where you are employed is actively working on 4RD. So if we are lucky, we can get the first implementations of A+P, like, I don't know, this year, next year. And if you can afford to wait for something that makes sense, just wait and test the new solutions that are coming out. If you don't have time to wait, then spend a lot of money in and think about how you will define your exit strategy.
Yeah, that's a good comment. Thanks.
I'm sorry we don't have any more time for the questions. Thank you very much for your presentation.
Thank you.